All right, so you're gonna like this. I went through and refactored all my code from previous days because I was tired of it being a mess with all the tests and the execution and everything being uh, all mixed together. So what I did was it was very simple. Um, I basically put all the code for solving the problem together at the top. Then I made a different section for the unit tests, which all go together. And then I made a final section at the bottom for solving the problem. So it's the same code, it's doing the same stuff, but it's much more cleanly separated. And so you can imagine that, like, if you were this were like a real program, I would put the unit test in like a test.py here. I don't want to bother; that's too much work. And then put this in like a main or whatever. So I'm going to try and structure my code like this going forward, just because I think it will be cleaner and neater. And I could be wrong. And if I'm wrong, then I won't do it. But I think it'll be nice. And I went back and did that on all the previous days. I like having that separation. So it was a huge mess to have, like, here's a function, now here's this capital raw thing, now here's another. Anyway, so hopefully by keeping it clean and separate, it will be nice. What is this a picture of? Is it someone skiing down a hill? Is it a spaceship? Why is there an extra space here? I don't know. But let us hope that it goes fast today, because as always, I am tired. 5, 4, 3, 2, 1, and 0. With your neighbor happily enjoying the video game, you turn attention to an open data port little screen. The port is not standard. You manage to connect it to your computer. The code uses several paper clips. Upon connection, the port outputs a series of numbers. Your puzzle input. The data appears to be encrypted with the exchange masking addition system, which is an old cipher with an important weakness. XMAS starts by transmitting a preamble of 25 numbers. For that, each number you receive should be the sum of any two of the 25 immediately previous numbers. Two numbers will have different values, and there might be more than one such pair. For example, suppose your preamble consists of the numbers 1 through 25 in random order. To be valid, the next number must be the sum of two of those numbers. 26 would be a valid next number, as it could be. 49 would not be a valid next number. 100 would not be valid. Suppose the 26th number is 45, and the first number, as it is more than 25 or so, is 20. Now for the next number to be valid, there needs to be some pair of numbers among 1 to 19, 21 to 25, or 45 that add up to it. 26 would still be a valid next number, as 1 and 25 are still within the previous number. 65 would not be valid, no 2. Here's a larger example. After the 5 number preamble, almost every number is the sum of the previous numbers. The only number does not follow rules 127. The first step of attacking the weakness is to find the first number on the list after the preamble, which is not the sum of the 25 numbers before it. What is the first number that does not have this? Okay, so I'm not going to try and be clever. I'm just going to do it by the brute force way and see if that works. Actually, let me look at how big puzzle input is. It doesn't matter because I'm only looking at 25 at a time. So with 25 at a time, that will be easy. And let's say raw equals, I don't want that. I want this to the previous 5 numbers. Okay, and so just put that there and say numbers equals int x for x in raw dot split on new lines, and we'll just leave that there. And so from typing import list, and what is it asking me to do? It is asking me to find the first number in the list, which is not the sum of the okay. So let me do this. Not sums, and we will say numbers, which will be a list of int, and look back, int equals 25, and that will be an iterator. Why is it an iterator? Because I'm weird. And and q equals dec. Okay, so for n in numbers, and let's say if len q is less than look back, then we just want to append n, and that's all. And then otherwise, we can say sums equals you know what, I'm not going to use a q because I'm just, it sucks, but sums equals a plus b for I, A, and Q, and enumerate Q for J, B, and enumerate Q if I is less than J. So we don't want to add up the same thing. And if n not in sums, yield n. And then what I want to do is I want to say q dot append n and q equals, this is, I shouldn't do this because it's bad, but that's a slow actually it's only of 25, that's fine. Okay. And so numbers. So what I want to do is I want to assert that next of not sums numbers with a look back of 5, that's why I made it parameterizable, is 127. So let's try running this, and that worked. Good. And so let's say numbers equals, again, int x for x in raw dot split on new lines, and print next not sums numbers with a look back of 25, it said. All right, let's try it. I'm not 100% sure that'll work, but that's the right answer. Good. The final step is to find, you must find a continuous set of at least two numbers in your list which sum to the invalid number from step 1. Again, consider the above example. In this list, adding up all the numbers from 15 to 40 produces the invalid number from step 1 to 127. Of course, continuous set of numbers in your actual list might be longer. To find the encryption weakness, add together the smallest and largest number in this contiguous range. What is the encryption weakness? Okay, so let us think about this. And how long is this? 1,000. So that's only 1,000,000. So we'll just do it by brute force anyway. Range some numbers, list int, and continuous set of at least two numbers. Okay, that sums up to it. Target, which is an int, and we're just going to return a list of int. So we're just going to do this by brute force because I'm too lazy to come up with a better way to do it. And what do I want to do? For I in again, enumerate numbers. J equals, or let's say J equals I, total equals N, and let's say while total is less than target, J plus equals 1, total plus equals numbers J, and then if total equals target, return, let's say slice equals numbers I, J plus 1. I want to make sure I don't have an off by 1 error, so I'm just going to say assert sum slice equals target, and return slice. What is this complaining about? And then just to make this happy, I'll raise a runtime error if I got here and I didn't find a slice. Okay, and so now add together the smallest and largest number in this contiguous range. And so let's just say def encryption weakness numbers, which is a list of int, and look back, which is an int, which is going to be 25, and that's going to return an int as well. And so what I'll say is that target equals next of not sums numbers look back, so that's just repeating the work from part 1. And let's say slice equals range with sum of numbers target, and I want to return, what was it, the min plus the max. Return min slice plus max slice. Okay, and so now I want to assert that encryption weakness of numbers and the above same example 576 is 62. Okay, so let us try running this, and that passed as well. So that's good. So let's print encryption weakness of numbers, and let's run that, and it gave me something. So let's plug that in. Good. Okay, so that was straightforward, and I'll tell you why it was straightforward. It was straightforward because I did not try and be clever, and I just did everything with brute force. Let me go back. And so what did we do? They basically said, I'm going to give you 25 numbers, and I want to make sure that your next number is the sum of 2 of those 25 numbers. Okay? And so, and then as I move forward, I'm only looking at a sliding window of 25 numbers. And so what I did was, so look, I wanted to use a queue because a queue is efficient to remove the first and add to the back and always maintain a length of 25. The problem is when I got to this line where I wanted to do this, I guess that would have worked actually. So I could probably change that from collections import deck, queue equals deck. So that would actually work, and then I can replace this with q pop left. Okay, because the problem is that when I was doing it with a list and doing that slice, it's linear. The list is only over like 25, so it doesn't really matter. But like this is really the right way to do it. So I said I maintain this queue. And as long as the queue doesn't have 25 numbers in it, just keep adding, each number to it. And then once we get to 25, I'll say the allowed sums are all the possible things I can get by adding up two different things in the queue. And this I less than j is what enforces the two different things. So, A has to appear before B in that list. And now I did this as an iterator just because it said find the first, right? And whenever someone says find the first, you know, you don't want to find all of them. And so conceptually, the easiest thing for me to do is to lazily find all of them, and then just use next to grab whichever one pops up first. And so that's where my brain goes with this, and that's why I did it this way. That sort of this is a lazy approach to generating them, and if I want the first one, then I call next on the iterator, and that works. And if I want all of them, I can just keep running the iterator until it stops. But anyway, so the moral of that story is that whenever I get something that's not in my allowed sums, I yield it. Then I push it on the end of the queue and I throw out what's in the front of the queue. So that's not sums, and that was, like I said, I just used next on it. For the second part, what they said was that whatever that thing is that I found, I went to find a range of numbers that adds up to it. And so again, this is the sort of thing where if you were interviewing at Facebook or whatever, they would probably ask you, what's an efficient way to find, a subrange that sums to a specified target sum. And there's probably some clever data structure that if I weren't tired I would think of, or computing, like running totals or things like that. Anyway, dynamic programming, whatever. I said, forget that. I'll just do it the brute force way. And so what I'm going to do is I'm just going to iterate over the numbers with like different starting points, right? And then with my starting point, so I start with I equals 0, and then I'll check I equals 0, I'll check I equals 1, whatever. So I check I equals 0 at whatever the number is there, and my ending point, I'll start with and it occurs to me there's a bug here, and the bug is that and I is less than j. So I think it's okay, because what happened was, so the way this code was written here, it's willing to return a slice of size 1, right? And that was explicitly disallowed. And so I guess the slice that had the data in it, or the right numbers in it, occurred before that number occurred, and so it didn't matter. But technically, what I should have done is so total equals n, and as long as the total is smaller than what I'm searching for, increment j, add numbers j to it, and keep going. And then I stop once the total exceeds the target. And technically I should probably do and j is less than len numbers. Because otherwise I could conceivably go off the end, which would be bad. Although if that did happen, then probably there would not be a solution, because but it's nice to be safe. And so if by doing this and I stopped, I got to the right number, and I is less than j, I take the slice, assert that its sum is right. Just I actually don't need that. That was just because I wasn't confident that I didn't have an off-phone error, return the slice. And now the encryption weakness, they said find the target doing basically what's in part 1, figure out the range that sums to it, and return the min plus the max. So that worked. And the only other thing I did that was interesting was parameterizing this look back, because in the unit test they wanted me to look back 5. And you can see that the way I split this up into here's the code at the top, like the library, if you will. And then here's the unit tests by themselves, which could be in a test.py file. And then finally, here's the actual like, and I need to remember I don't need to do all these things inside the with block. Only the read needs to be in the with block. And then once I've read the file in, then I can drop back out of the with block. So anyway, that's that. It worked. It was good. Thanks for watching. That was good. I'll see you tomorrow. Good night. Sleep well. Farewell.